Okay, we are going to cover a moment about an axis. I'm going to discuss that topic with you. Our approach, as always, is to introduce you to today's objectives first. You'll be able to determine the moment of a force about an axis using two methods, scalar analysis and vector analysis. As such, there are certain activities associated with today's topics. Reading quiz, applications, scalar analysis, vector analysis, concept quiz, group problem analysis, attention quiz, and that will be wrapping it all up. As you can see in this particular picture down here that's shown here, there's a force F that is acting. This is one of those a cargo type of a container loading and offloading used on our ports. It's pretty common. It's a well-designed machine. As such, as you can see, if there's a force F acting at the bottom of that, it could be a force of a container, a cargo container. There are points A and B, which are the base of this cargo at the end of the points in which they're connected to the ground. It is extremely important for such a machine to not have any overturning moment, otherwise it's going to just simply tip over as a result of the applied force. So when designing such a machine, we always make sure that we check for the applied moments. We look at different scenarios, different cases, and we look at the worst case scenario, and we design for that to ensure the proper operation of our machines. So question number one, when determining the moment of a force about a specified axis, the axis must be along A, the x-axis, B, the y-axis, C, the z-axis, D, any line in 3D space, E, any line in the xy plane. And the answer is the y-axis in this case. And the triple, question number two, the triple scalar product U dot R cross F results in what? A scalar quantity, B, a vector quantity, C, a zero, D, a unit vector, E, an imaginary number. And the answer is a vector quantity. Every time you have a dot product and a cross product presented as such, then you would have a vector quantity as such. So what are some of the applications of a moment about an axis? An example, an application, an applied example is given here. With the force P, a person is creating a moment M sub A that is about point A. Now, does all of M sub A act to turn the socket in this case? How would you calculate an answer to this question? Okay, another application, a sleeve of this bracket, it can provide a maximum resisting moment of 125 Newton meter about the x-axis shown here. Okay, this is the x-axis that goes through point A and all that. This is the x-axis. Okay, so how would you determine the maximum magnitude of F before turning about the x-axis occurs? Again, it's going to help us to design the sleeve and the bracket itself properly. Okay, so remember from previous lectures that the moment of a scalar force about any point A is M sub O F D sub O, where D sub O was the shortest distance, perpendicular distance from the point to the force's line of action. I'm sure you remember that. Now, this concept, we can extend it to find a moment of a force about an axis. Again, when we want to find a moment of a force about an axis, the calculations is going to help us with many different types of design, proper design. So let's take a look at a scalar analysis that's shown here. This is a wrench for a tire. As you can see here, the force F is applied, it is going to cause a moment about one of the points here, point O, as shown, and as such, we try to find m sub y. Again, the moment about the y-axis would be m sub y, which is f sub z times d sub x, or fr, the cosine of theta. This is for the dot product. However, unless the force can be broken into different components, and if you can find d very quickly, it's not easy to do this kind of a problem. So we're going to use the principles of vector analysis to solve such a problem. In this case, a body is shown, an axis of projection is given. Our goal is to find the moment of F, the tendency to rotate this particular body about an axis A. Again, our tendency is to find the moment of F about axis AA, a tendency to rotate this body. The first thing we do is we compute the moment of F about any arbitrary point A that lies on the axis, on AA axis, or AA prime axis in this case. Doesn't really matter. And we are using a cross product for that. We did this previously. We take the cross product. First we find the R, and then we simply follow you take the determinant of that as we discuss IJK and so on. The way we set up the matrix, we talk about that. We find a determinant, and that would be the M sub O. And then, of course, we would like to find after doing that, remember now it's going to give us the moment about a point O, but also it's important now to find the moment about the axis. As such, there will be we would be discussing how we can do that by taking the dot product of a unit vector along that axis by m sub O, and that would give us the moment about an a arbitrary axis A. M sub A prime A or AA can be obtained by the way it's shown here. What we simply did was, this is a combination of a cross product and a dot product. So the matrix setup would be different, and this really came from the equations. We can drive that, we skip it, but this is called the triple scalar product. Remember that with a R by F, the position vectors are, instead we are replacing it by U sub AX, U sub AY, and U sub AZ. That's the first line. The second line, so this is line 1, this is line 2, and this is line 3. So the second line, we would put the location of our position vector, R sub X, R sub Y, R sub Z. We're going to put the components in the third one, and we're going to put F sub X, F sub Y, F sub Z. What is basically changing here is that instead of having an IJK like we did with a simple cross product, we are having U sub A in the X direction. U sub A is, instead of having the IJ component, now it's going to have U sub AX component, U sub AY component, U sub AZ component, and that would be the first line. The second line and the third line, it basically remains the same as with a simple R cross F that we did before. So U sub A represents the unit vector along the axis that we are trying to calculate the moment about. R is the position vector. Again, it's from any point on the axis to any point A on the line of action of the force, and F is the force vector. Let's take a look at an example here. A force is applied to a tool as shown to open a gas valve. We are not concerned with the material of this tool at this stage. That's for comes into the picture later for the design. We would like to find the magnitude of the moment of this force about the z-axis of the valve. Again, we are going to discuss the triple, what I just discussed with you, triple scalar product. Again, I'm going back and forth and to also serve, this would also serve as a review too. So we're going to use the triple scalar product to do that. What would be the plan? The plan is, of course, you're going to use m sub z about the axis z, m sub z. We're going to use that as a u dot parentheses r cross f. Note that u is 1k. It's in the z direction, and the vector r is a position vector from a to b, and force f is already given in Cartesian coordinate system. So let's solve the problem. R sub a sub b is given as such. Remember, we know the distance, and it's going to be 0.25 sine of theta degrees I, 0.25 cosine of 30 degrees j, and u is also 1k. Again, it's only the axis is z-axis, and as such, u would be 1k. The f itself is also given, minus 60i, 20j, plus 15k, and we would like to find m sub z using this formula. Again, we set our matrix, and we just take the determinant of that matrix as such. And what happens here is that this is u sub ax, this is u sub ax, this is u sub ay, and this is u sub az. In this case, we only have 1k, so the rest would be 0. And the second one is for the r sub ab. Again, it's 0.125 and 0.2165. The k is 0, so there would be 0 number here. And the third row would be ijk component of that. So let me, I thought I lost the lecture. I didn't. I got lucky. So the third row, minus 60, 20, and 15. These are the components of the vector that is given in the problem. We would take the determinant of such a problem. First, we take the first column, first row out. Obviously, here we're going to have 0.216 times 15. Then we everything would be multiplied by 0, so that's 0. Then the second one is 0. And the third one, we're going to have 0.125 times 20. This is really what we're concerned with. The first two products, the first two parts of the determinant would turn out to be 0 because both of these numbers are 0. We are concerned with the third one, so it's going to be 0.125 times 20 and minus 0.2165 times minus 60 and multiplied by 1. That will be the determinant of such a matrix, and that would provide us with the moment about the z-axis. Let me talk to you about this concept quiz that is, we're going to go over it together. So let's take a look at this concept quiz. The vector operations p cross q dot r equals to what? A is p cross q dot r dot p cross q, p dot r cross q dot r, p cross r dot q cross r. So what would be the answer in this case? Well, this is p cross q, so this really doesn't work in this case. This one doesn't work. We cannot do it like that. P dot r, it doesn't apply. It's not the same way. The same rules that we do in plus and in addition and multiplication doesn't apply here. This one doesn't apply here either. But p cross q, whether I do this cross first, then multiply, then dotted by r, it doesn't really matter the way I write it. So it's equal to R dot P cross Q, and that is the correct answer. Okay, so another concept quiz. Let's quickly take a look at this. Force F is acting along DC using the triple product to determine the moment of F about the bar BA. You could use any of the following position vector except which one of these. Okay, let's examine the problem. We can use any of the following position vectors except one of them. We try to see which one is the one that we cannot do that. What's the exception here? We can use position vector RBC. We can do that. Remember, we're the force is acting along DC, okay, along this line of the C, okay. As such, we would like to find the moment about bar BA here, okay. This is where we would like to find a moment about this line that I just drew. It's a thicker line. We can use R sub BC. We can do that. We can use R sub AD. We can do that. We can use R sub AC. We can use that. We can use R sub BD, but we cannot use R sub DB because we're trying to find that the position vector, it has to go from B to D. It cannot go from D to B. So this is the answer in this case. This is the correct answer. Okay, the one that I encircled, answer D. Okay, let's solve another problem. Again, I've been solving a lot of problems for this course of problem solving to help you with your problem solving skills and to really help you learn the material. Statics is all about learning the theory and then do a lot of problems to be able to apply what we've learned. So sleeve A can provide a maximum resisting moment, as you can see in this case. We have sleeve A, it can provide a maximum resisting moment of 120 Newton meter about the x-axis. The maximum magnitude of F before slipping occurs at A is what we need to find out. So knowing that we would like to find the resisting moment about the x-axis and knowing the given value of the force, we should not have any problem knowing the magnitude of the moment. We're trying to do this a little bit backward. We try to find the magnitude of F in this case, knowing the magnitude of moment of 125 Newton meter. So problem is a little bit, we need to work backward a little bit, but don't be too scared. Obviously, the m sub x is given in this case. It's going to be, it is 125 Newton meter. This is our unknown. The unknown here for this problem is the force F. Okay. So we'll find R sub AB from here. We would find F in the Cartesian vector form, and we'll complete the triple scale product and solve for F. Let's take a look at the problem. So R sub AB is the position vector that goes from point A to B. So we can simply calculate that knowing the component of A to be at the origin of the coordinate system. That would be 0, 0, 0. So you should easily calculate R sub AB. Then the force in terms of IJK component, this is our unknown. Remember, we don't know the F, but we do know the angles. Those are given. So we're going to set it up in terms of the unknown. So F would be minus 0.5 F plus 0.5 F minus, I'll read that again, minus 0.5 Fi and plus 0.5 Fj plus 0.707 FK Newton. Okay. So now we would like to find the triple product M sub x u dot r sub ab cross f. We set it up and we just express the ij component of force in terms of f as unknowns. Okay. So the only unknown here would be f, which would give us the f max. Again, we solve this. The only component of a determinant would be when I cross these two lines out to be able to calculate the determinant of this matrix, 0.7 times 0.704 and minus 0.1 times 0.5. The rest of the components would be 0 because of these two zeros that I have up here. So M sub x would be 125 Newton meters. So I equate this equation, M sub x up here. I equate that to 125. Remember, there's only one unknown here. So 125 would be 0.162 F, and as such, F would be 771 Newton. Let's do an attention quiz here before I can wrap this lecture up. For finding the moment of the force F about the x-axis, the position vector in the triple scalar product should be which one of these? Remember, we've talked about this, we've discussed this. We would like to find the moment of the force F about the x-axis, okay? F about the x-axis. Can we have our position vector in the triple scalar product as r sub ac? Can we have it as r sub ba? Can we have it as r sub ab? Or we can have it as r sub b c. In this case, we would like to find that about the x-axis. The origin is point A, so we can only go from what? A to B, B to C. We cannot go from A to C, so this is out. We cannot go from B to A, this is also out. We cannot go from B to C, this is out. So the correct answer is R sub A, B. So the second question here, if R is 1I plus 2J meter and F is 10I plus 20J plus 30K Newton, then the moment of F about the y-axis is which one of these? We can simply calculate this and the correct answer would be minus 30. Try this on your own and make sure you get the correct answer. Let learning continue. That's the end of the lecture. If you have questions, make sure to send them my way. Thank you.